Hello YouTube, De-bodgery here. I wanted to dispel a false rumor that I knew was complete nonsense, and so I'm going to do that right now. So we are looking at parts that are from an EBMX X-9000, and specifically these are the bridges across the top. So this is the longest one. I scraped off the plating on there. You know, that's just to keep it from oxidizing. That's copper under there. By the way, this piece right here, which is the longest bridge, that is 30 square millimeters of copper. So, whatever that is, that's, I measured it. But anyway, yeah, this width, it's just a big square section there that comes out to 30 square centimeters. All right, so let's look at this one. This is the second largest bridge piece, and that was 27 millimeters square of copper. And give me a second, I gotta find the spot that I scraped off. There it is. So I tried to do these in random places on purpose. It's right here as soon as the camera focuses. There you go. Again, that's copper underneath that plating on there. This is a solid copper bar with plating on it to keep it from oxidizing. Solid copper, guys. All right, here is the shortest one right here. Let me flip this over. There we go. So I scraped her off around the hole and at the edge right here. That's solid copper, folks, and it's 36 millimeters squared of copper. I mean, this is no slouch right here. This is beefy stuff, and it is solid copper. All right, so now we're going to the power stage. So here it is, and I scraped it off right here on that part. And yeah, that's solid copper. That's not brass, that's not steel, that's not aluminum. Yeah, look how golden that is. And that's all of these things. So now I'm going to brag a little bit more on this stuff. Let me tilt this up so you can get a perspective edge on. All right, so this thickness right here, that is 6 millimeters thick. And the width of that is 14 millimeters. So this is 14 millimeters across by 6 millimeters thick. That's a big-ass hunk of copper. And this feature on the end, this bar used to be thicker, and they machined away a bunch of it just to make this little feature right here. Because there's no joint here. That's just one piece of copper with this, little cylindrical feature on the top of it, on top of the longer bar section. One piece of copper to make that. Let's move down here a little bit. So here's another feature, the same thing. That's not soldered on. Like all this stuff you see in here, that's the plating. That's not solder or something else. No, this piece right here was machined. You can see the milling marks in here. This piece was milled out of the same piece of copper as this was. It's literally a single continuous piece. And if you look down inside that hole, you can kind of see a little bit of solder paste in there, and looks like that's glue or maybe in there. So when you deal with big pieces of copper like this and you are soldering them down to an aluminum backed board, aluminum and copper expand and contract at different rates. So you need joints like this in it. And if you notice, it is a single continuous joint. There is solder in all of it. You look at it edge on. Oop, came out camera. See? There is solder all the way through. So there is literally no chance that you don't have an absolutely brilliant current path from here to here. And on top of that, that little gap right there, that's about a 1/2 millimeter wide. 1/2 millimeter wide. And it's filled with solder all the way to the top. No skimping. Nothing here is in any way, shape, or form starving or has a constricted current path. It is as perfect as you can get it. Yeah, it's all 6 millimeter thick by 14 millimeter wide copper. Let's move on down to this part. So again, this little feature is all machined, milled out of the same piece as this part. This is all one part. And we come down to here. Again, the copper has to be put together in sections on the aluminum board to relieve stresses. If you had one single bar that went all the way down, the board would warp badly. So you have to do it in pieces to create places for the copper to move at its own rate, which is independent, and I think it contracts slightly slower than the aluminum does. Anyway, you can see all the milling marks in here. So this piece again is a separate part, but you can also see the camera will focus on there. Yeah, look at that. It's a completely filled butt joint. There is no gap of any kind here. Completely filled with solder. And let me tilt this up a smidge so we can see. Come on, camera. Focus on the thing I want you to focus on. Okay. It's not cooperating. So this vertical part right here, there we go, kind of did it. And this piece down here, this isn't pieces. This part right here and this part right here were machined out of a single block of copper, okay? Yeah, no skimping on details anywhere here. This is so epically good, I cannot begin to express how amazingly good this is. So let's look at a phase bus. Here's a phase bus. So here's your low side MOSFETs right here. That's on the battery minus side. And here's your high side MOSFETs on your battery plus side. And this is soldered down to the board. And again, this is a single piece of copper with this vertical piece machined into it. It's not soldered down. That's one solid piece. And on top of that, you can see here, so this is a plastic washer, and there was one there, but it came out with a screw. Anyway, yeah, that isolates the screws from the copper so that this can be screwed down to the board through these things. So not only do you have this ridiculously large amount of copper soldered down, but then it also has two screws securing it to the heatsink. So when you wrench on these studs right here, come on camera, focus where my hand is. Focus up here. No, focus, focus. Yeah, it's cooperating. Yeah, so when you wrench on these studs, you can't rip them out. You can't tear them off. You cannot crank on them, at least not reasonably, hard enough to make those things come out. Or to tear them off, because they have two screws reinforcing them, and then the whole entire rectangle plate, including the vertical piece, is all a single block of copper. This is how you do it, folks. Yeah, this is excellent work. All right, so I'm going to talk about something slightly different. So if you'll notice here, and here, and here, and here, and here, every single MOSFET has a resistor and a capacitor on its gate. So this leg right here, on each one of these MOSFETs, is its gate leg. That's the leg that's the control signal that tells the MOSFET to turn on and off. And every single one of them gets a resistor and a capacitor. So the resistor limits how much current flows to the gate, and the capacitor cleans up high-frequency noise. And every single one gets that. People that care about what they're doing, they do this. Every single one gets that. People that cut corners, they might put like one set down here in the end, and then just bring traces over to all the different gates, and just run them off of a single resistor and capacitor. You know, that's kind of how FlipSky does it. That's how it is in the Komodo stuff. No, if you really care, you do it like this. Every single gate gets this stuff. And look down here. It's the same way. Next phase, same way. Next phase, same way. You see each single MOSFET gate gets its own resistor and its own capacitor. This is how you do it. If you really care, this is how you do it. All right, so yeah, if you notice, here is a MOSFET, and I'm pretty sure this is the drain right here. I think that's right. I need to look at the tall package to make sure, because otherwise I'm not necessarily being right, I'm guessing. But anyway, there is a solid trace that goes from underneath these MOSFETs, so up to about like right there. There's a piece of copper tracing. You know, exactly what this is right here. But it's bare, because it's got a big pad on here that's free, and you can kind of see the edge of it right here. But it comes down to about like right there. In fact, right in there, you can kind of see the edge of it. So it's about from this length all the way up underneath here, and then it comes up all up to here, and then it comes over to these legs of these MOSFETs. Because all this stuff has to get tied together. So you have this pretty damn large sheet of copper, you know, the circuit trace, that comes up to probably about like right here on these legs, and comes all the way down to here, all the way down to here, all the way down to there. And it's across this whole entire area. And then this copper phase block right here, this monster is soldered to it. So it's not a butt joint. It's not just plunked down on top of it and you're supposed to clamp it down. No, it's electrically attached right now. Yeah, it's not moving anywhere. In fact, the battery minus the battery plus studs, I tried to squeeze them and I tried to pull them off this board, and they don't move. They are there. Yeah, they're very, very soundly soldered down. Everything here is highly excellent. So anyway, one last detail before I let this thing go. I just wanted to put this whole copper, not copper thing to rest. So right here, that is a thermistor for this phase, and it's right next to the phase bus, right where it should be. Here is the next phase, and there is its thermistor right next to its phase bus. And here is the third phase, and here is its thermistor right next to its phase bus. This is how you do it right, people. This is how you do it right. No bullshit, no goofing around, no half-assing anything. This is how you do it. So when people have heard me say EBMX is doing a really good job, well, here it is. You're looking at it under my macro lens. This is called a really good job. No questions asked. This is called a really good job. All right, well, I think I've pretty well nailed that horse to the wall. Yeah. Anyway, hope that helped some folks out. I just wanted to clear up all of the smoke and all of the mud casting and stuff. There it is, guys. You can see the golden color of the copper glinting in there. These bars are solid copper, and they are soldered down, and they're held down with screws. All these spots in here, those get screws. All those get screws. All of these get screws, and they all have a washer in them to isolate the things. Yeah, this board is exceedingly well secured inside of its heatsink. It's not going anywhere. It is planted. So, yeah, good job, EBMX. This is awesome.